All right, so now we wanted to look at two application problems using first Google Sheets, and then in the next video we'll look at using Python to solve these examples. So the population example, something along the lines of what we were doing in class, was imagine if we started with a population of 5,230 and every year we added 91 and a quarter things to the population. So we created a new Google Sheet and titled the two columns, the population and the year, and we gave our initial values. Now we want to use this kind of sequence thinking to build the remainder of these values. So in this example, the next year is going to be 1991, or 1990 plus 1. So we're going to use a formula. We're going to say this cell equals this previous cell, B2, plus 1, and hit enter. Now if we go back to this cell, we can apply that formula by holding the bottom corner, and I'll drag it down to cell 30, and that takes us to the present year, 2018. Similarly, to generate the values for the population column, we're going to use a formula where these will equal the previous year plus 91 and a quarter. Every year we're going to add that many, and then we can also take this down to 2018, and we can see the different populations for the different years. Last thing we might want to do is to draw a plot of this. So I'm going to highlight the population column and insert it as a chart. Now the default seems to be to give me a column chart. I'm going to change this column chart to a line chart. I'm also going to add the x-axis, and the x-axis I want to be the years. And once we do that, we have a nice graph of our population through time. If we want to customize it more, we could add a title to this, population over years 1990 to 2018. We could change the font style, the size, the color, etc. So that's just a basic introduction to the use of formulas to apply in the population example. The second example that we had was about interest. So we had the problem where there were two students, both of them owed a certain amount, but they were going to face different kind of payoff scenarios. So again, I create a table with 3 columns, month, student 1, and student 2. I'm going to build out my months. This again is just going to be equals the previous cell plus 1. And I'm going to apply this down to the 24th. So actually, no, let's go to, so we have a full 2 years. Now student 1 starts with $4,400, and each month they're going to pay down $200. So this equals, the subsequent month will equal the previous month minus $200. And we can extend this out for 2 years and see if that student has paid off, and sure enough they pay it off in the 22nd month, it seems. Student 2 though was in a little different situation. They were going to also pay the $200 a month, but have interest at 24% annual percentage rate. That'll be compounded monthly. So they're also going to have the previous month in minus 200, but added on to that is going to be the interest applied to the balance of that account. So first we'll pay the $200 in interest, and then we are going to add to that 2%, which is the interest rate, because we here we had to, if we look at this formula, we divided the 24% by the 12 months to get the interest rate. So we're going to have the $200 taken away, but then we're going to add that 0.02 times the amount in the account, which is C2 minus 200 that we already determined. So you see the difference in the first month is going to be $84. So this second student has $84 more in their as their balance. And if we extend this out, we see that still after 24 months they haven't paid off the debt yet. So we're going to have to extend this further still, and it looks like at least 2 or 3 months. So I'll just continue this. Continue and continue this, and so it seems, yeah, it's not until the 28th month that that student pays that off. So finally we can create a graph of this. Again, we're just going to highlight the information, we're going to insert a chart, and okay, so one of the things that I don't need is, I don't want month. I'm going to add the month to be the x-axis. So I'm just going to say A. And now I have, I can change the title. Students' debt over time. And we see student 2 here takes a bit longer than student 1. This is 22 months, and this is 29, about 28, 29 months to go out. And we could change the number of months and customize the graph a bit, but it's just another introductory problem where we had a little more complicated formula, where first we were subtracting, but then we were adding interest applied to this amount on. Now we also want to notice that we have a common factor of C2 minus 200 of both of these, so we could have similarly just written this as 1.02 times C2 minus 200, and sure enough we get the same thing. And if we drag this down, we get the same values. Just a little more compact formula. Again, we talked about that 1+ rule in class. We'll look at it more in the future.